So here we have two vectors, vector A and vector B. They both have a magnitude of 8 units. Vector A is directed 45 degrees or 45 degrees counterclockwise from the positive x-axis, and vector B is 108 degrees, again, counterclockwise from the positive x-axis, or we can say in the direction of the negative x-axis. I have a Cartesian axis here where this would be our y and this would be our x, and we can see that this would be vector A, and with a 45-degree angle with respect to the positive x-axis. We have our magnitude of 8, and to find our x and y coordinates through trigonometry, we can find our x coordinate by multiplying the magnitude by cosine of the angle it makes with the positive x-axis. So here 8 cosine of 45 degrees, and for the y coordinate, again, it would be 8 sine of 45 degrees. So when we have then add these vectors, we would like to find the magnitude of the sum of these vectors. And so we can first say that here, if vector A leads us to 5.657, vector B would then be -8 in the x direction. So essentially, from the origin, we would end up at 5.657 minus 8, comma 5.657. Again, there is no y component to vector B. And so this is giving us, this is giving us negative 2.343, comma 5.657. And so we can then, to find the magnitude, we simply take the square root of the sum of the squares. Square root of negative 2.343 quantity squared plus 5.657 quantity squared, and we find that then the sum is going to be equal, or rather, the magnitude of the sum of the vectors is equaling 6.09 units. To find the magnitude of the difference, essentially, vector B is directly negative x-axis. So try to find the magnitude of vector A minus vector B. We're actually, when we're subtracting vector B, we're actually moving in the positive x direction. So here, the magnitude would be the square root of 5.657 plus 8 quantity squared plus 5.657 quantity squared. And we find that then the magnitude of the difference is 14.7 units. That is the end of the solution. Thank you for watching.